Hi students, I'm Praveen Sebastian Paul. In this lecture, we are discussing the race around condition of a JK flip-flop. So my dear students, in the lecture number 100, we had discussed what is a JK flip-flop, and in the last lecture we had discussed the characteristic table as well as the excitation table for JK flip-flop. If we are analyzing the truth table of JK flip-flop, if the clock is 0, then it will result in a memory condition, and if the clock is 1 and J0, K0 results in memory, clock is 1, J0, K is 1 results in a output of 0, clock is 1, J is 1, K is 0 results in an output of 1. Until this condition, both the JK as well as the SR flip-flop are same, and this is how the symbolic representation of a JK flip-flop looks like. And the final case is if we are dealing with a 1-1 condition. So now we are going to analyze what is the condition for the case of 1 as the clock and J as 1 and K as 1. Since the inputs are 1 and 1, the output of the NAND gate yellow and green depending upon the third input, that is, in the circuit we are providing the outputs of Q and Q complement towards the input of the first two NAND gates. So now let us assume that if we are starting with an output of Q is equal to 0, then this Q value, 0 value, is feeding towards the green NAND gate as well as the Q complement 1 value is feeding towards the yellow NAND gate. Thus, the output of the first NAND gate, that is a yellow NAND gate, becomes 0 and the green NAND gate now becomes 1. So if we are analyzing the red NAND gate, it is getting an input of 0. Thus we can tell that if any of the input of a NAND gate is 0, then the output will be 1. Thus the output of the red NAND gate will be 1, and thus we can conclude that the Q complement value will be 0. And next, if we are starting with these values, that is, the new value of Q is 1 and new value of Q complement is 0, and if we are starting with this Q as 1, this 1 is forwarding towards the green NAND gate, and 0 value of Q complement is forwarding towards the yellow NAND gate, and thus the output of the yellow NAND gate becomes 1 and the output of the green NAND gate now becomes 0. So according to this NAND gate's truth table, we can see that the output of blue NAND gate will be 1 since it is having an input of 0, and this value is feeding towards the red NAND gate, and thus it results in an output of 0. So now this 0 and 1 is the new values of Q and Q complement, and these values are feeding towards the input of the first and second NAND gate, and now the yellow NAND gate is getting an inputs of 1 1 1 and green NAND gate is getting an input of 1 1 0, and thus the output of yellow is 0 and output of green is 1. And here also we can see that the red NAND gate is getting an input of 0, and thus the output of red will be 1 and blue NAND gate will be 0. So this condition will continue until the clock signal is feeding as 1, and if we are not changing the values of J and K as 1. So this condition is known as the race around condition. So this race around condition and toggle conditions are similar, but one difference is toggling condition can be controlled, but the race around condition cannot be controlled. So if we are analyzing this value, the Qn plus 1, that is a present state, is continuously changing from 0 to 1, 1 to 0, 0 to 1 and 1 to 0. Similarly, the Qn plus 1 complement is also changing from 1 0, 1 0, 1 0, etc. like that. So this is a drawback of this JK flip-flop, that is, this is the race around condition. Now the truth table can be formed as the clock is equal to 1, J is equal to 1, K is equal to 1 results in a Qn complement, that is, the previous output value is complementing in these cases. So now let us check the clock diagram of this JK flip-flop. So we had discussed about the SR flip-flop, D flip-flop, and now we are discussing the JK flip-flop, and all these circuits are working with a clock of level triggering clock, that is, these circuits will work in either 0 or 1 condition, and thus these circuits can be called as a level triggered circuit. And here, if we are analyzing the clock is shown as in this figure, and in the case of J is equal to 1, K is equal to 1, the values of J and K is not changing, and thus it is a straight line with the value j and k is equal to 1, and now we are going to analyze the output, that is qn plus 1 value. So if we are analyzing the truth table, or if we are analyzing the circuit of this diagram, the qn plus 1 value is continuously flipping from 0 to 1 and 1 to 0 if the clock signal is 1. So if we are starting with the qn is equal to 0, then qn plus 1 had changed from 0 to 1 if the clock is 1, and it had changed from 1 to 0, 0 to 1, 1 to 0, 0 to 1, 1 to 0, 0 to 1 until the clock value is 1. So here in this particular time period, the clock had changed from 1 to 0. Thus, in this case, the circuit will continue to the memory condition as per this truth table of this JK flip-flop. Thus, the clock is equal to 0 yields in a qn plus 1 is equal to a memory condition. And now when again the clock had becomes 1, this circuit had continuously flipping its data. And in this case also, if the second clock's value had become 0, then the circuit becomes unchanged, and it will continue until the j and k values are 1 and the clock value is 1. So this is the clock diagram of a JK flip-flop with this toggling or race around condition. So as we mentioned, this race around condition is an unconditional value, and the toggling condition can be controlled with the help of some signals. So my dear students, if we are analyzing this particular clock diagram, we can see that the clock has a time period, and this time period is completely depending upon the clock signal we are using, and the circuit will be working based upon this time period of a signal. And all these particular flip-flop as well as any digital logical circuits and the digital components, all these components has a working period known as a propagation delay period. So before going to term this propagation delay, let us consider the half time period. That is, if the time period is t, then the half time period will be t by 2. Since we are considering a level triggered circuit, that is, we are considering a flip-flop, or this JK flip-flop is working with a clock signal of 1, we should consider the half time period of this particular clock signal. So t by 2 represents the half time period. So as we mentioned, a propagation delay of a circuit means any of the flip-flop will take some propagation delay. This simply means that the output value should be fed towards the input in a flip-flop circuit, and the propagation delay means the amount of times taken to the output to travel towards the input of a particular flip-flop circuit. This time period is known as a propagation delay. So in the case of a particular JK or any type of flip-flop, the time period should be greater than the propagation delay. Since we are dealing with a level triggered circuit, the half of the time period, that is t by 2, should be greater than the propagation delay, or reversely, the propagation delay should be less than the t by 2 time period. Then only the circuit will be active in the case of any of these flip-flops. So this is a condition. So now let us discuss what are the different ways to overcome the race around condition of a JK flip-flop. First condition is, if the half time period is less than the propagation delay, then we can avoid this race around condition. And the second one is, we can use an edge triggering circuit. Since all these circuits are designed with the help of a level triggered circuit, if we are dealing with an edge triggered circuit, we can overcome this race around condition. And the third and the most important as well as the most commonly used method is a master-slave flip-flop concept. So my dear students, this master-slave flip-flop is the most common as well as most widely used mechanism, and we are going to discuss about how to overcome this race around condition with the help of a master-slave flip-flop, and that will be discussed in the upcoming lecture. So my dear students, hope you had understood this topic. So dear students, kindly go through this assignment question. Our question is, write notes on the race around condition of JK flip-flop. So my dear students, in the upcoming lecture we will discuss how to overcome this race around condition with the help of a master slave flip-flop. So dear students, see you soon. Until then, goodbye, thank you and all the best.